Do you feel the vibes?
So, we're gonna shift gears a little bit, and we're gonna talk about how to analyze sets of data. Okay, so um, so based not today. So if you have like a data set, right? Um, we can look at different components of it and different measures to analyze that data. One thing we look at is what we call measures of center. And the most common measures of center are mean, median, and mode. All right. So mean and median, basically, like it's like the average and everything. So it literally looks at like the center of the data. Okay. The mean is what you all know as average, right? We don't call it average, we call it the mean. And it's the sum of the values divided by the total number. So you know exactly what that is. Okay, the median is literally smack in the middle of the data set. So when you have your data set and it's sorted in increasing order, exactly the middle point of the data is called the median. It's the middle value, or it's the mean of the two middle values. The mode is the values that appear most often. So suppose 100 people took a test, right? And you have all of their grades. And let's say like 3 people got 87s, and let's say 5 people got 84s. Okay? 84 is the mode because it occurred the most number of times. Okay? Okay, so let's take a look here. This is a table that shows the number of hits Marcus made for his team. We want to find the mean, median, and the mode. Okay, so for the mean, very easy. Just very straightforward. Right? Add them all up, and how many total values are there? 6 divided by 6. That's basically 26 over 6. That's 4.3. Okay. Next. Okay, for the median, to find the median, first we have to sort in increasing order. So let's see, there's a 2 here. There are 2 3s. There is a 5, a 6, and a 7. Okay, the center of this data is right here, right? Because you have 3 numbers to the left, 3 numbers to the right. The median, if the center doesn't fall on a number, it falls in between numbers. The median is the average of those two. So 3 plus 5 over 2, which is 4. So the median is 4. Okay, the mode is just 3 because that's the number that occurs most often. Don't say it's 2 because it occurs twice. No, it's just the number that you see most often. Okay. Now, so these are talking about the center of the data, right? When I find the average, it's basically like, where this is all centered. The median is like literally the center of the data. So that's why these are measures of center. Now, sometimes there is another way to analyze data, and that is called measure of spread or variation. Measure of spread, it's like, okay, now you've found the center. How close to the center are your scores, right? So for example, suppose there are 100 tests and the average is an 87. Okay, and now suppose all of the test scores, they go from 80 to 95, right? Do you see how close to that 87 the test scores are? Now imagine another set of tests, the average is also 87, but the grades range from a 65 to 105. Do you see how farther apart they are spread, right? That is called measure of spread or variation. Okay. One such measure is range, which is again very straightforward. It's the difference between the greatest and the least value. So the number of minutes Sarah talked on her phone each day this week is, all of these, right? One day she talked 63, another day she talked 21, 74, right? Okay, she must not have had any homework on the day she spoke for 74 minutes, right? And then, there must have been a math test the day after this one because she only had time to speak 21 minutes on the phone, right? So what is the range? Well, you have to take the highest and the lowest number. And for the range, you literally 74 minus 21, 53. It's as simple as that. Okay. Okay. Now, let's talk about quartiles. You can take a data set, and once you put it in ascending order, you can divide it into 4 groups. Okay, so suppose you have a data set here. Suppose you have 100 test scores. This is the minimum. This is the lowest test score. This is the highest test score. Okay? You can split this down the middle. So now you have 50 on this side and 50 on that side. That is called the median, right? The median separates the data into the upper and the lower halves. So now, you have the upper half over to this side and the lower half over to that side. Now, suppose you go to the lower half and you split that down the middle. This is called Q1, and it's called the first quartile or the lower quartile. This is the median of the lower half. Then you go over to the second half, you split that down the middle. This is called Q3. Q3 is the third or the upper quartile. Okay? And so the median, that becomes Q2. Okay? So you have Q1, Q2, Q3. All right? So now, each half is 25% of the data. So there are exactly 25 test scores in the first chunk, 25 in here, 25 and 25. All right? Okay. Okay. So then you have the minimum value, Q1, Q2, Q3, and the maximum value, and all those together are the 5-number summary. So let's take a look at an example here. Find the 5-number summary of the data shown below. Okay, so you always, when you have something like this, you always have to sort the data first. Now, for this one, I actually sorted it for you, so we don't have to do that. But once it's sorted, how many total values are there? How many? 11. Okay, so now you have to split it down the middle, right? Split it exactly down the middle. This is the middle value. This is Q2, or the median. Now, I have 1, 2, 3, 4, 5 on the lower side, 5 on the upper side. Okay, so this is the lower half, and this is the upper half. So suppose these were test scores, right? Or quiz scores or whatever. It's out of 55, all right? And these are the scores. So, what this tells you is exactly half of the students that took it scored 41 or above, all right? So often when I have like your test scores and I look and let's say like the average is, I don't know, like an 82 or something, but then I find the median and I see that half the class scored 89 or above, right? Those two kind of tell the same thing. Yeah, the average was 82, but exactly half the class got 89 or above. That means the average was a little bit lower because there must have been 1 or 2 really low scores. Okay? You see what I mean? So different aspects of this tell a different story. All right? Okay. So now in the lower half, this is Q1. In the upper half, this is Q3. Okay. This first one is the min. This is the max. So if I want to write my 5-number summary, okay, min is 25, Q1, 36, Q2, 41, Q3, 49, and max, 54. All right? That's the 5-number summary. So when you're asked for the 5-number summary, like, you have to know which numbers they are. Nobody tells you, oh, by the way, that's Q1, Q2, Q3, whatever. Okay. The number of boxes of donuts Josh sold for a fundraiser each day for the last 11 days were this. Find the 5-number summary and interpret the meaning. Okay, so first let's sort this data. Okay, so what's the smallest here? 14. And then there is a 16. You see how I cross them out as I'm listing them just so I don't miss any numbers. There are 2 17s. Yes, you write it twice because they're distinct values. There is a 20, a 21, and a 22. 26, 28, 29. Then there is a 35. And then, okay, so it's 11. Count to make sure that you've got all 11 here, right? Because you don't want to lose any data points. Okay, so this is the minimum. This is the maximum. If there are 11 total exactly in the middle, so this 21 is Q2. What's Q1? The first 17. And then the 28, Q3. Okay? All right. So now it says to interpret the meaning, and I kind of left this like open because I have an idea what I want. Depending on the context, right, this means different things. But right now, I just want to talk about what it is that each of these numbers mean, okay? So take a look at what this means. This person sold donuts for 11 days, okay? So 25% of the time, he sold fewer than 17. Right? He sold fewer than how many? 21, 50% of the time. Right? 75% of the time, he sold fewer than 28. Okay, does that make sense? You can also do it like the other way, right? You could say 75% of the time he sold more than 17. Half the time he sold more than 21. 25% of the time he was able to sell more than 28. All right? Okay, so I just want us to get used to all of these things. Okay. Now, so I kind of gave you like an idea of this earlier, right? How I said, okay, so remember, like there was that test score, the average or the mean was an 82, the median is an 87. So those two tell a different aspect of the story, right? So often you have to decide which value to use, right? So for example, suppose I do have a group of test scores, right? And one person, he came to class 40 minutes late. He came to class in the last 10 minutes and he sat and he took the class and the test and he was only able to get through like the first page. Okay, that person is going to score like a 17%. Okay? So that should not count in the average. That's going to bring the average way down, right? So what we do is maybe the average won't be such a valuable number in that case, right? Because there's a situation. It doesn't really tell, like mastery or whatever. Also, before we decide which aspect to use, we have to check for outliers. Okay, an outlier is a score that is really, really high or a really, really low score or a data point. But you can't just subjectively decide, oh my God, that really seems like too high, so that's an outlier. No, there is a metric, there is an actual formula, because this is math. Okay, we don't just, it's not about how we feel. Okay, so an outlier is an extremely high or an extremely low value, but what it is we have to look for values that are beyond the upper or lower quartiles by a specific number. What's the specific number? More than 1.5 times the interquartile range. Okay, that just became a lot of words. So let's just like sparse it up. There is this thing called the interquartile range, and all it is Q3 minus Q1. You take that number and you multiply it by 1.5, and we go from there. So why don't we go ahead and do that here? Are these scores sorted? They are not. Let's sort them. So I have a 45, a 71, a 79, 82, 88, another 88, 90, 94. Okay, what's the median here? It's between the 82 and the 88, right? You average them, your Q2 is 85. Okay. Q1, here. Q3, here. 89. Okay, we averaged those. Okay, now, the interquartile range is just 89 minus 75. That's it. That's a 14. Now what I do is I take that number and I multiply it by 1.5. Don't question it, just 1.5. So I get 21. So now, look at Q1. This is the magic number, 21. If I have a score 21 less than the 75, right, then that's an outlier. If I have a score 21 more than the 89, then that's an outlier. All right? So what I do is I say Q1 minus 21 is 75 minus 21, 54. Q3 plus 21 is 89 plus 21 is 110. So those are the limits for the outliers. Okay, do I have a number that's less than 54? I do, 45. So 45, whoops, that's not what I meant to do. So 45 is an outlier. Do I have a number that's greater than 110? No. So 45 is the outlier. Yep. No, there could be more than. There could be one on both ends. There could be two on one end and one on the, right? So the thing is, these are just so significantly far that you can't take them in the bulk of the other ones. They're usually removed. Okay, so when you're finding like certain things. Okay, so now let's see how this affects things. So what we're going to do is we're going to find the mean and the median with the outlier, then without. So with the outlier, the mean is 45 plus 71 plus 79 plus, plus 94 all over. How many of them are there? 8. 79.63. Okay, just take the average. What's the median with the outlier? 85. Okay? Now, I'm going to look at them without the outlier. Without the outlier, my scores are 71, 79, right? I took it out. The mean is going to be, when you figure it out, 84.57. Okay, what's the median now? 88, okay? The median is 88. Okay, so now take a look. Now let's take a look. When I took out the outlier, how much did the median change? 3 points. When I took out the outlier, how much did the mean change? More than 3, right? It's like a little bit more than 5, correct? So what does this tell us? The outlier doesn't affect the median as much as it affects the mean. Okay, so it really affects the mean, but it doesn't affect the median as much. Okay, so the mean is affected more by the outlier. Okay? All right, let's do this one. All right, let's do this one. Let's see if we can identify any outliers. Are these sorted? They're not. That would have been way too easy, right? Let's sort these quickly. So what do we have? Do we have a 10? Yeah. Oh, we have 1 10 and 2 11s. Any 12s? What else?
14, 15, 14, 3, 15.
What we have a 14. Where's the, okay, we have 2 15s? Yeah. 3 15s. How many 16s? How many 17s? I see an 18. 119. A couple of 120. A 21. 2 24s. No, 3 24s. A 28 and a 40. So let's see, this is 3 by 1 2 3 4 5 6 18. Do I have 18 numbers here? Yep. 3 24s. By the way, what's the mode here? I have 3 15s and 3 24s, huh? It's 15 and 24. You have 2 modes. This is called a bimodal data. 2 modes. Okay, so what are we doing here? Outliers. Okay, so how many did we say we had? 18. So where's 6, 7, 8, 9? That's the median. To find the outlier, I don't really care about the median right now. But then where's the Q1? Is it 15? And then here, Q2, the first 24, right? Yes? Yeah. Okay, so outliers. So the interquartile range is 24 minus 15. How much is that these days? 9. Okay, so 1.5 times 9. 3 over 2 times 9, 27 over 2. How much is that? 13.5. Huh?
I miss Aiden because he does it.
Right? Thank you. And you all, I feel like, have had too much hamantashen today. And like everybody's like falling asleep after that sugar rush. What's going on? Okay. So how are we going to do this? What are we going to do? Subtract what? 15 minus 13.5 is how much? 1.5. And then 24 plus 13.5 is how much? 37.5. So any outliers? Yes. 40 is the outlier. So we do this number minus 13.5 is this. This number plus 13.5 is this. So now you have to see, are there any values less than this or greater than this? Those are the outliers. Okay? So now, here's what we're going to do. You ready? Okay, so we have the median. The median with the outlier is 17. The median with the outlier is 17.5. Okay, so this side of the room, I want you to find the mean with the outlier. that side of the room, I want you to find the mean without the outlier. On your mark, get set, go. Okay. What? Swan. I know. Okay. What'd you all get? Were you with the outlier?
Yes.
What'd you get with the outlier?
19.
Just even? Yeah. Oh. What'd you all get without the outlier? 17.8. Okay. How about the median? So if we take out the 40, right? If we take out the 40, now I have this. What will be the median here? How many values do I have? So that would be 17, correct? Yes? So do you see how, again, the mean was affected more with the outlier, by the outlier, than was the median, okay? So here's a little bit of like Jeopardy trivia for you. This median is called a resistant statistic because it resists those changes, whereas the other one is called a non-resistant statistic. Okay, so next time you're at a party, you can impress all your friends with that one. Okay, so let me give you guys a handout here.
Press start.